Okay, so if you have not seen the video on solving exponential equations with a common base, you may want to go see that first. So we're looking at exponential equations without a common base. As we can see, our 2 does not equal 4. Well, it's very nice that we can convert the 4 into a base 2, because 4 is the same thing as 2 times 2, which can be written as 2 squared. So what we're going to do is we are going to substitute out for here just the 2 squared. So that becomes now 2x raised to the 2 squared power that is squared. Now, properties of exponents says that when we have a power raised to another power, we take and multiply those powers. And I'm going to demonstrate that later with something else, but we now have 2 raised to the x power equals 2 raised to the 4th power, which is x would then equal 4. And we can actually see when we do that, if I take 2 and I raise it to the 4th power, that would be the same thing as 4 squared. So 2 raised to the 4th power is 2 times 2 times 2 times 2. I'm just expanding this out. And 4 squared would be this, and 4 times itself 2 times. And 4, of course, we know is 2 times 2, and 4 is 2 times 2. And I can see that I have 1, 2, 3, 4 2's here, and I have 1, 2, 3, 4 2's there. So normally I would not use something with a base 2 to explore that because of the properties of 2. 2 is one of those what we consider kind of a magical number, because you can take 2 plus 2, and that's equivalent to 2 times 2, and that's equivalent to 2 squared. So sometimes when you're trying to prove something, 2 is not a really great base, but it also is a really great base to a really great number to work with if we're just trying to prove something with a small number. Okay, so let's go on to another one. Let's do, let's see, how about this one? How about if we had 5 raised to a number equals 25 cubed? What would that number be? So again, we can convert this 25, that is 5 times 5, which can be written as 5 squared. So we're going to just substitute for this circle here. We're going to put in that instead of 5 squared. So again, we have 5 raised to the x power equals 5 squared, and then that's going to be cubed. So if I was to expand this out, we would have 5 squared times 5 squared times 5 squared, because that's 5 squared cubed, and 5 squared would be 5 times 5 times 5 times 5 times 5 times 5, which gives me 1, 2, 3, 4, 5, 6 5s. So again, I would want to take and multiply these two numbers together so that it is both base 5 raised to the 6th power, because we're trying to find out what x is. 5 to the x is 5 6. Now we could drop our bases, so x equals 6. You may have something that has I know you don't like fractions, but you may have something that's a fractional value. So we may have something that might be 49 raised to what power is equal to 1 over 7. Okay, raised to the 2nd power. And I bet you guys are going, what? Those aren't even the same thing. Well, yeah, we can get there. We can get there. Okay. So 49 we know is 7 squared. So what we're going to do is we're going to say that this is 7 squared raised to the x power. And we want that to be equal to 1 over 7 squared. So that would be 1 over 49. Now what we're going to do is we want this to both be a base 7. The problem is that we have a 7 here and we have a 7 here, but one can be written as 7 over 1 squared, and the other one is 1 over 7 squared. If we could just get that 7 squared to go up above, that would be great. Well, this is what is called the property of negative exponents. Negative exponent is that we don't like writing things with negatives in math generally. So when we have fractions, and I'm just going to go ahead and use R2s as an example. So if I had, no, 10, I'm going to use 10 as an example. So this is a side work thing. So if we had 100 and we divided by 10, that would be 10 squared minus divided by 10 to the first, which gives us 10 to the first, which gives us 10 to the first power. And if we divide that by 10, we get 10 to the first divided by 10 to the first, which of course is 1. And that would give us 1, which would be also 10 to the 0 power. So here we're going 10 squared, 10 to the first, 10 to the 0. If I take 1 and I divide it by 10, I get 1/10, but I'm also reducing this by a exponent of 1. So that becomes 10 to the negative 1 power. So that's what happens. This is how we get a negative exponent, because 10 squared is 100. And then we divide out a 10. That we take away 1 from the 2, leaves us with 10 to the first, and 10 to the first divided by 10 to the first gives us 10 to the 0 power, which is 1, and then 1 divided by 10 gives us 1/10, which gives us 10 to the negative 1 power. So now we can rewrite this as 7 raised to the negative 2 power is equivalent to 7 squared raised to the x power. All right. These are almost identical. So what we need to do is we need to say, hey, I can multiply these two together, makes that 2x, 2 times x. I can drop my base 7 equals negative 2. Therefore, if I divide both sides by 2, x must be equal to a negative 1. Now, this would be one of them that I would prove using a graphing calculator. So let's go over to Desmos. Where's Desmos? There we go. Desmos. And sometimes I can get these to be very nice. So remember, we have 49, and we think it's going to be raised to the negative 1 power. So we're going to hit this button here, and then negative 1, and gives us that. And we also had 1 divided by 7 squared. Okay, why is it? Yeah, those both are the same numbers, as you can see. Let's see if I can take a screenshot of this. We got 0.20408, 0.20408. It does indeed give us both the same values. So I wonder if I can take a screenshot of this. I should be able to. I don't know where my screenshot thing went to. There we go. Oh, okay, come back, come back. I just want to take a screenshot of that so we can, come on. Oh, I hate when that does that. Okay. Give me this. Give me, okay, how about a screenshot? That's one my computer would know exactly where to go. All right. Let's see if I can take a screenshot. Just want a, come on, pen. Don't have a snipping tool on here either, do I? All right. Anyway, I'm not going to fight with it right now. Okay, so that just gives you some idea of what we are doing if we do not have a common base. We try to get them to both be a common base, and then we always go in and verify our results with our graphing calculator if possible. All right.